In the previous year, we have learned some of our substances which are in our everyday life. That is, some of the substances like Rita, Shikakai, also you have learned how they are useful for us. But here now, in the 9th standard, we are going to learn some more substances, and we also want how they are prepared, what are their constituents, and how they can be used. In our everyday life, we use different substances like metals, non-metals, acids, bases and salts. Salts are very important because many substances are in the form of the salts what we use every day. Can you classify the substances which are you using every day? Can they be classified under this group, that is metals, non-metals, acids, bases? Because it is very easy for us to classify the substance into this group. As we know how to classify them and how to test. The acids will contain H positive ions and alkalis will contain OH negative ion, that we have learned in the previous chapters also. So what we want to learn about it? Can we take any paper? So we have learned about that also, that we can use pH paper for that, and that pH paper which shows us the concentration of H ions, that is pH value of the given substance. See, we can prepare a solution of the given substance in a test tube, take some water and put that substance and then put the pH paper in it. That color of the pH will change accordingly the property of that substance. If the pH is between 0 to 7, it is an acidic substance, I know. Then if it is 7, then it is a neutral substance, and if it is greater than 7, it is an basic substance. This much we have studied in our previous chapters of the acid and bases also. See here, to find out what the pH paper is and what to detect whether it is a acid or basis, we know something about the salts also, because in nature many substances occurs in the form of salts. Generally, what are salts? The substances which does not contain any molecule of H ion or OH ion. Both the radicals, that is positive ion and the negative ion, are other than H and OH. Then we call them as salts, like NaCl. So we use different substances in our everyday life for different purposes. So what are the purpose and what the substance we use in that? Let us say something about this. That is, the use is about cooking. So in cooking, which chemicals we are using? That is about the baking soda is a common name, and besides that it is a common salt also, because we every day use these substances in different types of substance. With that, vinegar and all acids and bases are also there. But other than that, suppose for our education, what we need? This for education, we use different types of pencils. These pencils are made up of one of the important non-metal, that is carbon, then the ink also, then paper also, that is ink, then paper. These are all substances chemically prepared in the different industries. Then we can say that for the cleaning purpose, in our everyday life, we need to clean so many substances, starting from us only. For bathing also, we need soap. For cleaning also, we need bleaching powder and like that. Okay. So, these are the different substances. Of course, we can have soda also, that is washing soda, or detergents, different types of detergents we use, and they are for our cleaning purpose. See, I am classifying the substances in the according to their use, and then I can use them in different medicines. Okay, The medicines are also prepared by different types of chemicals, and we can use these chemicals to repair ourselves or to cure our diseases. Then the important is, suppose the clothing or our shelter, that is cement concreting or POP like substances we use in everyday life. And the better we can say in the entertainment also. Entertainment. What is important is, in the entertainment, our digital life, which is very important, is based upon the chemicals and the radioactive substances only. So here we can list this, and the list will not end because it is very long. In our everyday life, different types of uses are there. The only and the major source, I will not say only, but the main source of these salts are sea. See, what is sea? In the sea, when you test the water in the sea, you can see it a salty one. Why? There is every day, you can say that 80 million tons of salt get dissolved in the sea water. This is not only the common salt, but before that any other salts are also there. And so, sea is a rich source of all these. Which salts are there? See, we can see from the sea the different types of salts we can obtain. The main type is of course NaCl, then we can say it is MgCl2, magnesium chloride, like that magnesium sulfate, then we can say potassium chlorate, then we can say of course this is calcium carbonate is in the form of all, you can see the Shankha Shimple, what you call it, and we see the calcium carbonate is there in a major source, and then of course the other substances are also there. But before that, we can take these substances and test it, as I have told you, and find out their pH value, so that you can use this pH value to find out whether the substance is basic or acidic or neutral. The pure water is neutral, you know, its pH value is 7, and many strong acids and strong bases react together to get a strong or the neutral salt, and so you can say that NaCl is also like a neutral salt, and like this we can list our salts and can study them. Are you ready to find out some of the important salts in our everyday life? Okay, so we will try to list some of them, that is 4 or 5, because here we cannot take all the substances, find their constituents, how they are prepared and what are their uses. So the first one, which is very common, of course it is a common salt. So we will start studying our different types of common used substances. That is, they are generally salts only. The first one is a common salt, or it is known as table salt. So what is table salt? It is also known as common salt, and its salt, and what is its chemical formula? The chemical formula is NaCl. Okay, so this is the chemical formula. According to chemical formula, what must be its chemical name? So chemical name is sodium chloride. So this is our first salt which we are going to study. About its properties first. We will list some of the important properties because they are given in our book also, and you can read. You can find out some more information also if you want from the Google or the websites given in the book, and then find out as many as information about this particular salt. So that not this particular salt, but the salts which are going to learn in this chapter. So how is NaCl? You must have seen every day in your house that NaCl is a white powder, what we use it. It is a colorless, of course, then colorless crystalline form. You can see the powder form also and a crystalline form of salt also. But the important thing is that these crystals doesn't contain the water of crystallization. You must have seen about the water of crystallization because it is a crystal but doesn't contain a water of crystallization. So first I will write it is as a colorless, or you can say the powder will be the white one, and when it is a colorless crystalline salt, and the major important properties, it doesn't contain water of crystallization, water of crystallization. So then you can make it melt also. When water of crystallization is not there, you can heat this powder up to 800 degrees centigrade and make a fused state of it. So it is in a molten state then, but it will not contain water, but that can carry the electric conduct, that can carry the electricity. And so if you pass electricity in this molten state or the fused state of it, you can say that you can collect the sodium at the cathode and chlorine gas at the anode. So you can find the sodium metal also pure form from this table. But generally this common salt, if you can get its solution, that is a saturated solution of sodium chloride, is known as, of course, barine. When the saturated solution of this basic salt, this is a basic in nature, and you can see the saturated solution is called brine. Okay. See, this brine also you can pass the electricity through it, and what happens, you can get by electrolyting it, that by the electrolysis, what you get is H2 and Cl2 gas of it. And what happens to this Na part of then? Because it is an aqueous solution, I can say that NaCl plus H2O, because it is a saturated solution, there is a much part of this water also, and it will get you NaOH and then H2 plus Cl2. These two gases can be evolved from this, and this is a very important salt. So to get this salt also, you can have this brine, and that is the saturated solution, and you can find out the electrolysis of it, but not the saturated solution in the fused state. Fused state means, of course, in a liquid state, but how it is forming the liquid? At the temperature of 800 degrees centigrade, it will be in a molten state, and in this molten state, you can say that it can conduct the electricity, and then only from this molten state you can have sodium and chlorine gas. That is you can obtain sodium metal from this. So what are the important uses of it? This is how we have found out their properties, that is about their crystalline structure, about its molten state. But it is so common that we know that it is salty to taste and therefore used, salty to taste, and therefore it is used in the each type of food. The food taste cannot be complete by the salt. When the salt is there, then only the food will be tasty. And so here you can say that this brine, again one important part of it, that is suppose that 20% of this brine, that is 20% concentration saturated brine is given and 1/5 of it is evaporated, then you will get the crystalline sodium chloride in a pure form and it is a saturated. So, this is also one of the method to get the solution, because from where we get it, common salt you know, from the sea only, and it is in an impure state because it contains some other salts also like magnesium chloride and all. So, if you want it in a pure state, then the 20% of the brine solution, 25% of the brine solution is concentrated to 1/5, that is it is evaporated, the water in it should get evaporated and the basic you will get the crystalline and amorphous NaCl in it, okay. And so this is about our NaCl. Can we write some other salts like this also? Let us see. So, the next substance is our sodium bicarbonate, okay. This is also very common in use, that is sodium bicarbonate. What is it? This is its chemical name, that is in chemistry it is known as sodium bicarbonate, but in our everyday life we call it as a baking soda, okay. So, what is its chemical formula then? When bicarbonate is there, it is NaHCO3. What you know about this baking soda? For what purpose your mother uses this baking soda in the cooking purpose? See, when that baking soda is used in cakes or in bhajiyas or in dokla, what happens? They go to inflame, that is their volume increases, they looks like a puffy one and it tastes also good. If the soda is not used, then you will see it is a very tough cake will be there, it will not puff out and then it will not taste also. To make the bhajiyas crispy, what the mummy says, that I have put some baking soda in it and so that it gets puffy and crunchy also, okay. So, what is the reaction of this baking soda with this food stuff, so that it gets puffy and tasty also? See why they are used in some bread. So, the bread and the cakes, these are important, like that the doklas will also be there and some bhajiyas will be there. Or in some substances, when a substance is not easy to be cooked, we put some soda in it, or that is a baking soda, so that it can be cooked very easily, like our rajma and all, when they are not easy to cook or they can be cooked only after half an hour or 45 minutes will take for general cooking. If you put a soda in it, it can be cooked faster. So, what is it? Of course, it is a whitish substance, of course, and it is used in these bhajiyas because there is one chemical reaction of it. Suppose I say NaHCO3 is heated, then what will happen again? NaO, but before that what we generally do, we put some acid in it. So, I will add some HCl and the chemical reaction will be NaCl plus H2O plus CO2. This CO2 when coming out of the substance, it will be some type of perforations and so it will be puffed out. That CO2 rushes out from the substance and so it gets fluffy. So, due to this CO2 it is, and due to this NaCl there is a taste also, and so it is a very important substance in our life. Then of course, it is used in the second way, I will say that it is used in a fire extinguisher. Why fire extinguisher is used? To produce CO2 to control the fire. How the CO2 will be produced? See here, this CO2 is produced with the NaHCl and NaHCO3, that is baking soda and the HCl. How it is used? You can see there is a fire extinguisher like this, and in this fire extinguisher there is a kept here the powder is there which is NaHCO3, and there is a little bit capsule of this acid is there. So here there is an acid, and whenever we break this, what will happen? And from here there is an outing for the CO2 and one handle will be there. See what happens? When this fire extinguisher, we keep it inverted and then we have a stroke on it. So this bottle breaks down, HCl reacts with this baking soda and then CO2 is formed. Otherwise washing soda also can be used here, but generally it is used because the water is also forming and we can have this CO2 also, and this CO2 will cover the fire whatever it is burning and can control the fire over there. So we can use this sodium bicarbonate in our foodstuff as well as in the fire extinguisher. Which next? See, it is very small, we cannot go deep into its crystalline form and whatever it is, but we can see the next substance as a bleaching powder. So what is bleaching powder? You must have heard this name. Where? Can you recall your memory and find out where the bleaching powders are used? You can see that in this rainy season, sometimes our water smells differently, or there is a different smell of for a water in your swimming pools. From what that smell comes from? It is a smell of a chlorine. From where this chlorine comes out to be? From this bleaching powder. So main constituent of this bleaching powder is chlorine, and it is known as CaOCl2. So what can be the name of it? That is calcium oxychloride. Calcium oxychloride. Is the chemical name of it. You can have your bleaching powder in your house also. Sometimes we use it in our bathrooms or in our basins to do the disinfectant, that is to be clean, and there should be, if any bacteria or any type of pests are there, they can be cleaned. But you can take one important test of it. Take some colored cloth piece and put some bleaching powder on it and some wash, then you can wash it. You can see that the color of that cloth is gone and it becomes the white. That's why it is called a bleaching powder. It bleaches the color, that is, it changes it, the color is gone and it has become the white. If your whitish shirt is not enough white, then you will say that bleach it so that all the dust particles on it or all the whatever the different colors are on it will vanish and it will be a perfect white shirt you will get from it. So what are the chemical reactions of this bleaching powder? You can say that this bleaching powder smells of the chlorine also. So when you keep this open, the powder must be kept in a tight stock so that airtight ढक्कन should be there, because if it is open and comes in contact with carbon dioxide in air, then it start reacting it and the chlorine gas will go out. As the percentage of chlorine is reduced, the quality of bleaching powder will also reduce, and so as we can say, the quality of this bleaching powder depends upon the available chlorine, that is called as the available chlorine. What do you mean by it? That is, if it is open, some of the chlorine is gone out and some of the chlorine is only remaining it. So how much chlorine is available from it? Only 100% or 70% or 50%. Then you can say that it is of the lower quality. And you can say that for your house also you will not get an 100% chlorine powder, because it will be dangerous for you also, because the smells is very high, and so it is very difficult also to smell that bleaching powder whenever it is thrown inside the bathroom and all. So you can wet it and take a smaller or the lower quality of bleaching powder in our everyday use. But for the water purification, because it is a disinfectant, chlorine is a poisonous gas, and so you can use it for the purification of water. And in that purification of water, where the waterworks are there the bleaching powder is mixed in it, and you get the smell of that water to your tap water. That is the smell of the chlorine, because there the chlorine, that is the bleaching powder, is used as a disinfectant. In the rainy season, generally the water is mixed with mud, and therefore there are so many bacteria and viruses which are coming from the water to in our tap, and so it should be protected from that. So what we will say here, the first property of this is this is a colorless, of course, and have a smell, that is a stinky smell in it. So first of all I will write here, it is a colorless and having a smell of chlorine. Okay. So chlorine is the most important part of it, because when you have the smell of water in the swimming tank also, when I say that from the swimming tank, you must have told, when out of the swimming tank, wash your body from the clean water. Not that swimming water is also a clean water, but there the percentage of chlorine is higher, and so that chlorine on your body can have the effect on it, and so it should be gone clean, and you have to wash your body before going for the your life. And then here when it is open, one important thing, that is you have kept open, in the carbon dioxide from the air will react it, and what will happen? See, when the calcium is reacting, it will form the calcium carbonate and chlorine will go out. So it is calcium carbonate plus chlorine. So chlorine gas is separated. Now when chlorine gas is separated, its importance will also reduce, and the main use of it is used as disinfectant. And besides that, it can be used. You want this white paper. So these paper are made up from the tree pulp. That trees are not white, you know. So you will get a brownish or blackish paper from it. But if you want a bleached it, then this color will go and you will get a very clean and white paper which you will love to write. Like that, white powder also, that is the sugar. The sugar is also, when in a raw material, it is a yellowish or brownish. But if it is bleached properly, then it will become a white, snow white powder, and then you will get of course the crystalline form is also there. So this can be used, bleaching can be used in the various types of pulps, that is the paper pulps or any different types of material also for the bleaching it. In the different laundries also, they do the bleaching of the clothes and they can clean the clothes also. Okay. So here is one more important use of it, is as a disinfectant also, and in the paper laboratory, in the paper industries. From this I will write one more important reaction of it, that is, if it is mixed with acid, that is H2SO4. What will be done? CaSO4 will be there, then H2O and Cl2 will be given out. Now here you can see that the property of bleaching powder is due to the chlorine only, because chlorine is has a property of disinfectant, that is the killing the microbes in it. Then why we are not using the chlorine as a gas? Because gas is very difficult to handle and difficult to spread also. So what we do? We turn this chlorine into a substance, that is a solid substance. How? By combination of CaOH2. And CaOH2 when treated with chlorine, you will get that CaOCl2, that is bleaching powder, and then of course here the water is formed. When it is in a solid state, it is very easy to handle, and then we can we can use it in a very convenient matter. So to spread it or to mix in the water, or so whenever we want to use it, we can use this solid substance very easily. But only thing is that this substance should be kept in a tight airtight container, so it will not come in contact with the carbon dioxide, otherwise it will decompose slowly and the chlorine will go out, and the quality of that bleaching powder will be reduced.